All right. So find the derivative of this following function here. So f is equal to arc sine of x minus 3. So this is the same as sine inverse. Okay, just real quick, in case you didn't already know, arc sine x means sine inverse x. It's just a different notation. So what we're going to use is the sine inverse formula that I put somewhere. Let's see, PDF is right there. Derivative of sine inverse or arc sine will be 1 over the square root of 1 minus x squared. So that x is going to be whatever is inside the inverse function. Okay. So our x is x minus 3. So the derivative is equal to 1 over the square root of 1 minus x, where our x is the argument, 1 minus x squared. Okay. Does it make sense? This is my x right here.
Yeah, you're using that formula to plug it in for x.
Yeah, so let's look at the answer. And we're almost done. What do you think they did?
They just distributed it like a factoring it out.
Yeah, pretty much. You just gotta multiply that out, right?
Yeah.
And then combine like terms. And you're done. So all you gotta do is follow the formula for this section. So 1 minus x squared minus 6x plus 9. One minus x squared plus 6x minus 9 would be, let me stop sharing this, sorry. It's going to be negative x squared plus 6x minus 8. So nothing crazy, right? Let's do number 3, I guess. Any questions on number 1? Okay. So this will be arc cosine of x over 7. So arc cosine, let's find the formula. So here it is. So it's going to be the same thing as sine, except it has a minus sign. And our x is going to be x over 7. So the derivative is 1 minus x over 7 squared. Any question on this? 3 was right here. So, I mean, technically you could do it this way. Let me show a little extra step. I feel like I skipped a step or two.
It's kind of like the first one, right? Except the first one doesn't have the 3.
Pretty much.
Okay.
If I leave the 3 on the side, I think it's more obvious.
Right.
Just remember that this is negative 1 minus x over 7 squared, which is negative 3 over 1 minus x squared over 49. Any question about these steps? All right, 1 moment. All right. This section doesn't seem too bad, right, so far? Okay. So the next couple of questions is the same type of thing, except they're going to have product rules. You see this? This is going to be a product and a chain. This would be a chain and a product. So let's do, I say we do number 4. 4 looks like a good one. Problem 4, we said. No. Yeah, 4. So g of x is equal to e to the 3x arc sine x. So the derivative will be a product rule, which will be the derivative of the first term. I'm going to show the formula first before I do the derivatives. So derivative of the first times the second plus the second times the derivative of the first. The derivative of the e to the 3x is going to be a chain rule. So it's itself times 3 to the derivative of the top. Do you guys remember the chain rule for this one? Is that clear?
I thought, okay, so that you just do chain rule for that one, right? That's all it is, just. I thought it was just what it is like itself, like it would just be e through the x.
Yeah, you're right. It is e to the 3x, but then you have to multiply by the chain rule because it has a 3x up there.
So
Right,
if it,
because you did it both.
yeah, so if it didn't have the x, then it would just be
Yeah,
three then.
yeah. If it was e just regular ex, it would just stay ex. But you could think of it this way: like if you have an e to the x, your derivative of that would be itself times the derivative of the variable. But most of the time, it's
okay.
since that's just the one, it never really matters. But here we have this derivative. It'd be itself times the derivative of that inner function.
I see. That makes sense.
All right, and then this guy is just e3x, right? Derivative of this will be 1 over one minus x squared, right? So finally, get it all together. This will be 3e3x arc sine x plus e3x over the square root. You could technically factor e3x out of the entire thing, but you don't have to. They did here, but it's the same thing. Any questions on these steps here?
So basically, like, we applied the subs that we just did on the last few problems, apply it to this, and then as we were like expanding it, we took the derivatives of it, and that's why like 3x went in front of like the e arc sine, and then the e3 dx went on top of that that fraction, right?
Yeah, so we did Get a product rule here on the second line. And then that product rule tells you to get rid of this one and this one. This is the chain rule type. This is the new stuff, just using the formula. And then after that, we just have some algebra to do.
Okay.
So honestly, this section is it's going to be the same thing you've been doing in the last few sections, except you have inverse trig functions to worry about. So that's the only new thing. So all this homework will look very familiar. So it's going to test you on chain rule, quotient, product, all the same stuff. It's just that you might see an arc sign or arc cosine. Does that make sense? You want to do another one? Let's see here. This one has two arc functions with the chain rule in it. It looks like they're going to cancel out and give you a 0. This has a product rule, and during the product rule, you're going to have a chain from the inside. This will just be the formula. That I showed you. Actually, let me see. One moment, please. I think I might have forgotten something. Number. No, we're good. They just added these fractions. Sorry, I was wondering if I made a mistake, but no, we're good. If you notice over here, you have a 49. So all they did was well, actually, if I factor a 49, yeah, let me check that formula. I feel like there should be a chain rule here because this had a 7 on it. So it should be this times the derivative of the inside, which would be 1/7. Yeah, that's where I messed up. So right here, everything's good. All you need to add here. Just multiply by this derivative, which will give you 1/7. For example 2. Now, if you notice, they have this here. So how did that happen? What they end up doing, which I don't think is necessary, you could have left it like 3/7 in front. What they did is they threw the 7 inside. So if you bring a 7 into a square root, the 7 turns into a 49, right? You agree that square root of 12 is equal to square root of 4 times 3, which is 2√3, right? You remember doing that stuff? So if I bring the 4 back in, that would be 4 times 3, right? If I bring the 2 back in, does that make sense? Is that weird? So what they did was bring the 7 inside. So there's an extra step here that I forgot. There should be 49 times this. And that's how they get their answer. They just bring the 7 inside and multiply times both pieces. So this is the 7. And that 7 came from the derivative of x over 7, which is 1/7, right? So over here, oh no, this one didn't have anything. This one was fine. Any questions on number 2? Chain rule that I forgot. Is that clear? All right.
Why did they put the 49 on the outside for example number 2?
Why did they what?
Why do they put the 49 on the outside on example number 2?
This 49?
Yeah.
So they're just they're just making it prettier with algebra. It's not doing anything. All they do is bring the 7 inside as a 49 and distribute. So this looks nicer.
And they got that one from the exponent, right? And they plugged it in for x.
Yeah, this came from squaring that guy. So x squared, 7 squared is this, x squared over 49. And then the 7 goes in and turned it into this.
Oh, I was referring about the one.
This one?
Yeah, no, the other one on the fraction of 1 over 7.
Oh yeah, you're asking what that derivative is, or what about it?
Yeah, that it's 1 because they put that one from the exponent in the x. That's what I'm asking.
Yeah, so this came from the chain rule because of the derivative of the inside. That's what this is. So this is just like saying derivative of 2x is 2. Derivative of 1/7 x is 1/7. You see what I mean? That's what this is. That's why this became a 7th.
Oh yeah, I know. I was just worrying about the number 1 on top. That was all. That's what I mean. Like, how did you get 1? Like, just yeah. Is it from that part or?
Well, that's just from the formula, right? Derivative of this guy is this.
Okay.
And 3 is just I left it to the side.
Okay, so you just took the 1 out. You just left the 3 on the side.
Yeah, I just did 3 times -1. So derivative of this is this piece times the chain rule. The 3 isn't doing anything.
Okay. I was
Yeah.
just trying to
3
make
times
sure I understood
-1
why it was.
is here. Yeah, it's just right here. It's just this one on top. That's all it is.
Oh, okay.
So I got this piece from the derivative of the arc cosine. And then the 3 is just attached to it. It's not
Okay.
doing a single thing. Sorry, I wasn't sure what you meant.
No, you're good. I overthink things a lot, and I'm just like, well, what's that? Why is that there?
No, it's okay. I appreciate the questions. It's good that you asked. That's as many as you like. Okay, So that was number 2 and 3. This one looks annoying. Let's try this one. Great. And I'll leave some for you, I suppose. Okay. This time I'll be careful enough to forget the chain rule. It's going to happen again here. And then there's a chain rule inside of the root. So the derivative is going to be, so this first part is a product rule. So the derivative of the first part times the second part plus the first part times the derivative of the root for the second part plus the derivative. I'm just going to go ahead and put the quote. I'm not going to do it just yet. Okay, so let's do derivatives on the next line. Derivative of x is 1, doesn't do anything. But the x is gone. Derivative of this will be a chain rule, so that will be it'll be 1/2 times 4 minus x squared. So 1/2 minus 1, that's the outside derivative, times the derivative of the inside. I'm going to put brackets on this. Derivative of this guy is going to be 1 over the square root of 1 minus x over 7 squared times the derivative of x over 7. All right, running out of space there. Let me simplify and make space. So this is square root of 4 minus x squared plus, I'll leave it the way it is here, the bracket. So 1/2 minus 1, that becomes 1 over, well, hold on, let's won't skip a step. I'll put -½ first. Derivative of this guy will be times -2x, right? Derivative of this is -2x. Derivative of this guy is going to be 1/7. So now we have 1 over 7 times the square root of 1 minus x squared over 49. You guys still with me up to this point? Okay. So 1/2 times a -2, those cancel. That'll leave me with negative x over the square root 4 minus x squared plus 1 over square root of 49 times 1 minus x squared over 49. So at this point, we're pretty much done. Just algebra we're doing here. Any questions on this? This problem? The Homer went one step further and they combined the first two terms right here. But other than that, it's the same thing. Yeah. X squared inside. Does it seem straightforward? Or are we just all tired today?
No, it seems straightforward, I would say.
I'm hoping that the fact that it's repetitive at this point, it'll help you solidify the chain rule and product, etc. All right. I think after this is look at another. Well, let's look at the schedule first. I think that's all for this section. This for section 3.7. Today's Tuesday. Yeah. Okay, let's look at Newton's method. So let me look then for 3.8. So one moment. Newton's method is a technique to approximate zeros of any function. Any function that is differentiable, I should say, because the formula requires a derivative. So this is usually something you do like in programming because it takes many iterations. Doing that by hand is kind of silly, but here's the idea. So if x sub n is an approximation of a solution of f of x equal to 0, and if the derivative at xn is not equal to 0, the next approximation is given by xn plus 1 equal to xn minus f of xn over f prime at xn. So if this is 0, the 0th term, then this is the first term. If this is the first term, then this is the second term. So you keep doing it over and over again in a loop until this formula converges to the 0. That's the idea. Let me show you a visual from the internet because I don't have my book open. So basically you choose some point on the function. Let's say the red line is the f. So you pick an x naught, the formula does a tangent and derivative, calculates it, you get closer, calculate it again and get closer. You keep doing it until you approach the intersection of the x-axis. In other words, the 0 of the function, if it exists. So that's what this formula is for. Okay. Basically, and most calculators and computers can do that for you. They'll calculate, most likely have this already inside. They will find it for you and tell you what the 0 is. Okay, so let's look at some examples. This is the formula we're going to need. Here's the definition and theory behind it. So it starts off by you just plugging in numbers, kind of like when we did limits. So it should look familiar. So they ask you, okay, well, first, what is xn? The first one is 2. So that goes here. Then they ask you, what is the function at that number? Well, you plug in 2. Then you take the derivative and plug in 2. Then you divide those guys. And then you put it all together. So basically they're building the formula piece by piece to make it easier on you. I don't know if that's easier, but I think that's what they're trying to do. So eventually all this together gives you x2. So this is equal to the next term, right? That's what we said on the paper. We said all this nonsense is equal to the next one. And then if you use this one and do it again, right, then you'll have the following point and so forth. So you can keep doing it. Here they only did it once. So we can make this bigger. You only did it one time. So the first term and the second term. Where's the homework at? Well, that's not the homework, that's just the solution. Here we go. So that's all they want you to do here. Same thing for that one. And we'll do one of them in a second. I'm trying to see if there's any different stuff here. Okay. Yeah, we'll look at this one in a moment. I see. So well, let's do the other one before we talk about number 5. Well, let's do number 1. Any questions on this formula, what the notation means?
What does that say? XN?
Yeah, this is x n plus 1 down here. And this is
Oh, okay.
n xn. So these are the ones before this one. And that'll make more sense once I do the example, I think. Calculate 2 iterations of Newton's method. So they give us F and they give us the X1. So the X1 is the first iteration. So the formula basically is saying, well, give me X2, right? That's the next one. So that would mean that I would have to use the previous term, X1 minus f of X1 over the derivative at X1. So do you see what the formula is saying, right? If I want to find the 2, then I use the 1. Once I find 2, then I can find 3 using the 2 plugged in. And you keep doing that forever. The more you do, the more accuracy you get. Kind of like the calculator, right? It'll give you a bunch of decimal places and eventually you stop. Of course, we are not robots, so we're only going to do it a couple of times to get the idea. Does this setup make sense to you?
Yes, sir.
All right, so this is a derivative. We're going to need a derivative, so let's go ahead and do it over here. If you've done any programming, that should be pretty familiar, this type of iterations. And if you haven't, then we'll figure it out together. Okay, so let's go ahead and the way they did it is they did it piece by piece, right? So they said first plug in the 2. Well, first plug in X1. They have a 1 right here. X1. They gave us that already, so 2. Who cares? Then they say, well, plug in f of xn. We're using 1, so f of x1. So you plug in 2 inside here and see what happens. So we're going to do the same thing on paper. So x1 is equal to 2. It's the first piece. F of x1 is equal to f of 2, which is equal to 2 squared minus 5. That gives me -1, right? Now we do f prime of x1, which is equal to f prime of 2, which is 2 times 2. Then they ask us to do f of x1 over f prime of x1, which is going to be -1 over 4. So again, that's all they did here. You see that? That's where they got the -1, the 4, the -1/4 is the same as 0.25. Put it all together and you get this answer. So the final answer will be, so x2, we wrote the formula right here, right? That would be equal to 2 minus -1/4, right? which is 2 plus a fourth, which is 2.25. Any questions on number one? You see how we're just using a formula, right? So let's do number three, but this time I'm just gonna do it all at once instead of doing these little pieces. Okay. Calculate two iterations. Of Newton's method. Remember, Newton's method is approximating to zero, right? The f they gave us is cosine, and x1 is 0.7. Okay, so we need to calculate x2 because x1 is right there. So x2 is equal to x1 minus f over x1 over f prime of x2. So we're going to need the derivative. Derivative cosine is negative sine. So x2 is equal to x1 is 0.7. So this becomes 0.7 minus f at 0.7 over the derivative at 0.7. Right? So 0.7 minus cosine of 0.7 over negative sine of 0.7. These double negatives will cancel. So 0.7 plus cosine of 0.7 over sine of 0.7. Either way, at this point, we should be using the calculator. Could have used it a long time ago. Okay. All right, so 0.7 plus cosine of 0.7 sine of 0.7. So this is what they really want you to do. Just find this number. Okay. So we get round to how many? They said 4 decimal places. So this is approximately 1.8872. So go back to the question here. So we found we had x1 and we did a second iteration and found x2. I just didn't plug in all these numbers. That's all. They go ahead and plug in the x2 in here and x2 there, whatever. But in essence, that's what we're trying to do is find the next term. So if you were to do like, if they ask, I don't think they do, but if you wanted x3, then you would then use that number. So you see how you can keep going, right? So that would be 1.8872 minus f of 1.8872, the derivative at 1.8872. So doing this again will give you the next term. And if you keep going, it'll get more and more accurate. That's all we're doing. We are estimating the zero of the function. Is there any questions on the idea or calculations? So we can kind of already see what the zeros at, right? That's going to be pi over 2. So we're getting closer and closer to this number. So right now we're at 1.88. So if we do it again, right, we might get closer to this. Just for fun, let's just go ahead and do it. 1.8872. Oh, actually, I could just use this up here. .8872. 0.8872. Yeah, check it out. We're closer to pi over 2, right? On the third iteration. We're almost there. So if you keep going, eventually you're going to get all these digits, like very close. Is there any questions on the theory or this example?
No, sir.
Okay. So remember, we were saying that this helps you approximate a 0, right? So that's what 1 through 4 is all about. Get closer to the point that makes the function 0. Over here, they're asking you to apply the method to find the intersection point. So this is not a 0. So you just adjust this to make it seem like a zero, like it's approximating a zero. So what you do is you subtract them and you set it equal to zero. Then that will be your F, I guess. So for number 5, we are given two functions that are intersecting. Let me write them down, then I'll switch over. So in order to approximate the intersection, we say let h of x equal 2x plus 2 minus square root so we'll just find the zero of this guy. That's the same as finding the intersection of these two functions. Okay. Do you guys see why that's the same? Right, to find intersections, remember, you just set two functions equal to each other, and if you subtract it, you would set it to 0, right? And that's where this comes from. So let's do the approximation. So based on the graph, I mean, we can pick whatever we want. I'm going to pick something kind of close. It looks like it's somewhere between, somewhere below 0.5 and above 0. So I don't know. We could use 0.2 or 0.1 maybe and see what we, as our starting point, because they don't give us a starting point. It doesn't seem like. So we will choose it. So let x1 equal 0.1, I guess. Okay, so let's use our formula. So the formula says x2, the next one will be x1 minus the function at x1 over the derivative at x1. So I'm going to need, well, I'm using h, so I'm going to change this to h. So h prime will be 2 minus, no, it's going to be an ugly one. No, it's okay. It's not too bad. Right. Bring the 1/2 down, subtract 1. Get rid of the inside of the 1, so we're good. So plug in the numbers. So x1 will be 0.1 minus h of 0.1 over h prime of 0.1. So h on the top, we're gonna have 2 times 0.1 plus 2 minus the square root of 0.1 plus 9. divided by the derivative, so that'll be 2 minus 1/2 times 0.1 plus 9 to the negative half. So this is a calculator problem now. Maybe the whole thing is, but 0.1 minus, so that'll be 2 times 0.1 plus 2 minus square root of 0.1 plus 9 over 2 minus 0.5, 0.1 plus 9 to the negative 1/2, which I'll use as 0.5. So all this garbage, it's going to be this. Okay, so .5452. So now we'll do it again and see if it differs by 0.001. So check it out. It wants me to do it until there's almost no difference. Okay. I need to make sure I didn't do any mistakes, otherwise this will be frustrating. Yeah, looks like we're good. Okay. So do it again. X3 is equal to X2 minus H of X2 over H prime at X2. So that will be 0.5452 minus H of 0.5452. H prime will be 0.5452. Let me make more space. So this will be 2 times 0.5452 plus 2 minus the square root of 0.5452 plus 9 over 2 minus 1/2 times 0.5452 plus 9 to the negative half. Okay, what is that going to be? I don't know. So 0.5452 minus the fraction, a space here, minus the fraction of 2 times 0.5452 plus 2 minus the square root of 0.5452 plus 9 over 2 minus 0.5 times 0.5452 plus 9 to the negative, parentheses. Okay. So what is the difference here? Looks like X3 is 0.54 4, 7. So it looks like it only changed by 0.001. So at that point, we would stop. That's how they got this. So they did it twice, the iterations. So they found X3 and they noticed, oh, it's not changing that much. So we're good. Looks like their zeros right there. The one I was looking at earlier was it's a different example, but anyway, does that idea make sense? You just subtract them and apply the formula.
Yes.
It can be tedious, to be honest. But okay, so that's pretty much it. I think what we have left is, so at this point, I guess on what's today? Today's Wednesday. So Monday, I'm not. Let me think. One moment. Let me look at this.